So welcome to our class. We're going to look at hypothesis testing. Now, hypothesis testing for exam questions is usually conjoined to estimation and sampling. So before we go any further, it is imperative that you know how to read these tables. This is like an X-ray to a doctor for a statistician. Only you could be able to understand. So these are probabilities that you're given here. So they are called Z values. Now these Z values here that have been given are read as follows. If you're given a Z value, for instance, 1.23, the way you read this one is you go to 1.2 and where they meet 0.03. That would be the reading there. Are we together? So I'll do this one and you help me with the other ones. So 1.2 is here and 0.03 is there. So they're meeting at a probability of 0.8907. So that is a probability 0.8907. So meaning if my Z is 1.23, the probability is 0.8907. I can even read it backward. If I'm asked to check inside the table, the probability, which is 0.8907, what is the Z? I'll just check inside the table and simply say this one, I just add 1.2 and 0.03. Collectively, it will give me 1.23. 1.23. So suppose I was told to find 0.9130. It may not be exact as this one, but the closest. I can still pick this 0.9130, meaning the Z here will be 1.3 and 0.06. So this is 1.36. All right. So a quick exercise we can do. Give me the Z for 1.96. The probability. This is for the ladies. For the males, give me the Z for 1.28. Quickly. What is Z for 1.96? What is Z for 1.28? Ladies, 1.96.
For the gents is 0.8997.
1.28, so 1.2 under 1.28 under 8. What did you say?
0.8997.
8997. That's correct. The ladies.
0.9750.
1.96. 0. What?
9750.
9750. Okay. Now help me read from inside the table. Suppose I've asked you to find 0.9800. This is a probability. The ladies, you give me the Z for equivalent to that one. The gents, 0.9880. 0.9500. Okay. Which one is equal to exactly 8900 and 9500? Males. So look for them inside the table. What are you finding?
For the males 1.655.
So 1.6. So each of these ones is equal to, so 1.645. So 1.64 or
4.5, yeah.
1.645. So you start with the smallest one, then add a 5 to it. It was equal, but if it was to the nearest, you can even get 1.65 or 1.64. Better than the rounded off figure. It's the same thing. For the ladies,
I think 2.56.
0.98. 0.05. Right. Now, how to read the tables is very important from the knowledge that I've just taught you here. So we have what? 99%. The difference from 100 is a significance level, which is 1%. When you convert to decimal, it's 0.01. And when you divide it by 2, 0.005. When you subtract it from 1, we get 0.995. Then let's read this from the table inside. 0.995. Which one is equivalent to that? 0.995.
It's 2.5, 4. That's 995. Yeah. 2.4.
0.58.
Yeah. Yes.
So 2.58. Okay, let's go to 98%. What do we put here?
%.
And here?
0.02.
Yeah.
It should be 0.01.
Yeah.
And there it's 2.96.
And here is what? When you check this one in the table, 0.99. Check it from the table. 2.33. Are you seeing the order? I want you to try 97% on your own. Let's see. Try 97% on your own. Okay. 3%. Then here. 2.03. Then here. We have 0.015.
5.
Yes. Then here,
0.985.
985. Then here, 0.985. I sent you the tables, the groups. Then here is 2.17. Right? 95%. In a nutshell, we'll not do all of them, but what you need to know is that these ones are the most common ones. Here, I'll redeem you. I'll just say you find it at 1.96. When you get 90%, this is the same as what? 10%. It's the same as 0.10. Here, I'll redeem you. Here, you're going to get 1.64. So we made a sum. Since these are the ones that come here. 99% is 2.58, 98% 2.33, 97% 2.17, and 5% 1.96, and 90% 1.645 or 1.65. So this is our song that we need to know. With that being said, quickly, the three topics: sampling, mainly, if you're given to say, find the sample size from a population whose standard deviation is 4, the error is within ±2, and we're also told that our alpha is 0.05. And also we're told that by B, find the sample size of a population whose proportion is 20%, and the error is within ±80%, and the confidence level is 98%. So there are two formulas that we've just discussed here. Number one, the sample size formula, where n is equal to z s squared over e squared. So from our sum, we need to know that this is the same as 95%. 95%, the z is 1.96. So this must be in your head. So we know 95%, what is the z? Everything is pointing to the z 1.96. Sometimes they'll give you in terms of the significance level 5%, what is the z? 1.96. Sometimes they'll give you in terms of the alpha 0.05, what is the z? 1.96. It's the same thing. That's why it's important to have this table in your head. So here we're going to have 1.96 from the 0.05. We square that. And our standard deviation is 4 squared. If this was given as a variance, you don't square it because this is already squared. And the error is what? 2. So when you compute that, 1.96 squared times 16 divided by 4, we're going to get 15.37. In part B, we can't use formula 1 because we're given a proportion there. We're going to use formula 2. So our Z, which is coming from 98%, we know this is 2%, which is 0.01, it is 2.33. So where the Z, we're going to put 2.33. So here we're going to put 2.33. In our proportion P, 20%. So meaning Q will be the remainder 80%, 0.8. So here 0.2 and here 0.8. So divided by the error is within 30%. If it's a percentage, we convert it to our so we have times 0.2 times 0.8 and divided by 0.3 squared. So here our sample size will therefore be 9.65. This is our sample size. Okay, so I want you to try. Suppose you're given to find the sample size, and we're told that the variance here is 25, and our error is within plus minus 5. Then our level of significance is what? 10%. In part B, we're asked to find the sample size, given that our P is 15% and our error is within plus minus 4%. Can we calculate our sample size? Who wants to try? The ladies, part 1, and the gents, part 2. Let's start with the ladies. What format do we use here to find the sample size?
So that's n is equal to z squared, s squared over e squared.
That's our Z. That's our Z from 10%. Need to master that. What is our Z?
1.64.
1.645. What is our S? Squared. What is our error? Alternatively, since we're given variance, let's put 5 there. Don't square it, was already variance. 1.645 squared times 25 divided by 25. So 1.645 squared is 2.7. Right. And sample number 2, the jets, what format do we use?
The proportion one. N is equal to z squared PQ over error squared.
What is it?
I didn't see the CI there.
So if you
Do we
don't,
have
what's the standard?
95.
5%, correct. And our P?
The P is 15, 0.15,
And the Q?
0.75. That's 85, sorry.
Then 0.04 squared. So we have 1.96 times 0.15 times 0.85 divided by 0.04 squared. So you get 306 as a sample size. Then we also have confidence interval, which I said is given by mean plus minus z, standard deviation over square root of n. The other one is the proportion. We're given confidence interval is equal to p plus minus z dq over capital N. So if we're given, for instance, to find the confidence interval at 98%, where sample size is 36, and standard deviation is 12, the mean is 10. Part A. Part B, find a 99% confidence interval where our capital N is 50, our small n is 30. So Question number one, we use formula number one, confidence interval. What is our mean? Question number one, our mean is what? 10 plus minus. What is our Z at 98%? The Z is what? 2.33. Then standard deviation is 12. Our N is 36. So when we square root the 36, we get what? A 6. 6 into 12 is a 2. So 2 multiply the 2.33, we get 10 plus minus 4.66. So here we're going to have 5.34, and upper bound we're going to have 14.66. For the second one, we're not given the proportion, but whenever we're given two sample sizes, a small sample size and a bigger sample size, proportion is simply a small population out of a bigger population. If you have 3 girls out of a class of 10, the proportion of the girls in the class is 30%. So if you have 30 out of 50, our P is equal to 0.6, meaning the remainder is your Q, which is 0.4. And now we can use this formula here. For confidence interval, where there is P, put 0.6. Where there is Z, since the 99%, remember 99%, what is our Z? 2.58. Then we have PQ in there, square root. So our P is 0.6, our Q is 0.4, and we use a capital N here, not the small n, which is 50. So here we're going to have the following: 0.6 times 0.4 divided by 50, and we square root it, multiply by 2.58. You're going to get 0.1787. So in this case, we're going to subtract 0.6 minus 0.1787. 0.6 minus 0.1787, you get 0.4213. To increase it, we're going to add to get 0.7787. So here you come in to say my true proportion will be between 42.13% to 77.87%. It's a true proportion. But here our true mean is between 5.34 and 14.66. So this is how we look at estimation and how we look at sampling. But how do questions come for estimation and how do questions come for sampling? Well, this looks too easy, and they're accused of bringing simple questions. Exams sometimes look at something else. So I've sent you some questions on the group so that we could.
So, Mr. Collins.
Yes, sir.
So this calculation under estimation, isn't it?
Yeah.
It's combined.
It's under estimation and sampling, yes.
All right.
Any other questions? Any other questions? Before I look at the questions I've sent you on estimation, I've sent you some questions on estimation. So let us look at how the questions come now. Are we ready? So I'm going to beam a question and we can answer based on what has been just discussed here. All right. So we are told that a random sample had an average of 78.25 and a population standard deviation of 22.50. We are asked to calculate a confidence interval at 40 and at 75, and also deduce the difference there between the confidence intervals. So let's look at this question here and help me identify what has been given in the question. So what has been given in this question? Let's identify. Number one, X bar. What is our X bar? 78.25. What else have we been given? Standard deviation. 22.50. So part one, we're being asked to find a 90% confidence interval. Can somebody lead us through? Let's go through where the sample size is 40. What is the formula? What formula we're going to use here? X bar plus minus Z standard deviation over root of n. So here our mean is what? 78.25. And our Z here at 90% will be what?
1.64.
645. 1.65. And our standard deviation is what? 22.50. And our n here is what? 40. And part two, find a what? 90% confidence interval. But the difference here is that our sample size now increases from 40 to what? To 75. So when we calculate our confidence interval, what are you getting? The ladies, you can do part A, the gents, you can do part B. Quickly, then we comment on the difference in the intervals. Can you go through?
Sorry, I'm getting mixed up. Which one is the upper bound and the lower bound?
The lower bound is the lower value. The upper bound is the higher value. So is this what we got for the sample size of
the one that's being calculated with a positive is a what?
It's the upper bound.
Okay.
All right, so did you get these answers correct? If you did, then you're doing a good job. So I've sent you homework on your various groups. So we're done with.
Sorry. So the order in which you calculate doesn't matter, negative, or does it matter?
It matters.
Whichever sign you start with.
You have 10 plus minus 2. You first start by subtracting 10 minus 2 is 8. Then 10 plus 2 is 12. So this is 8, 12. That's the order. This is the lower bound. And it's the upper bound. As simple as that.
Okay. Thank you.
Right.